Lesson 2.3 in Trig is going to talk about solving right triangles. So at first it's going to seem like a big review from your geometry or possibly your Algebra 2 experience with right triangles. But before we get into that, I want to talk about significant digits or significant figures. Now I want to keep this as similar to your science class as possible. So when we do Sig Figs, and I'll be honest, I'm not going to make a big deal about it in this class, but just so you know how the answers from the answer key are coming up, you count all digits from left to right, beginning with the first non-zero digit on the left. So as an example, if it's 0.0062, the first non-zero digit is a 6. So following that, you have 2 digits, and that's why there's 2 significant digits. 1.498 has 1, 2, 3, 4 significant figures. 5.02 is 3 sig figs because the zeros that are in the middle also count as significant figures if they're trapped between 2 non-zeros. So 30.05 has 4 sig figs. Now, I added a decimal point here to make it consistent with your science class. If you had 50,000 with a decimal point after it, that means you have 1, 2, 3, 4, 5 significant figures. So if we have 0.0003, that just has 1 significant figure because he is the first non-zero digit from the left. And then 0.0304, you start counting here and you count 1, 2, 3 sig figs. Now the rule in this textbook, if you're ever looking in the back as to why they rounded their answers the way they did, if there's 2 sig figs in the problem, then you round your angles to the nearest degree. If there's 3 sig figs, then you round to the nearest 10 minutes, which is the same thing as a tenth of a degree. So as an example, you would round 45.23 to 45.2. That's just an example. And then if it's 4 sig figs, you'd round to the nearest minute or the nearest 100th of a degree. So that would be 2 decimal places. So as an example, 16.76, just as an example. So that's the way the book is going to round. If you look in the back for an odd problem, I'll be honest, I think rounding that much in a trig problem, especially in application, is kind of stupid because sometimes you'll end up with a triangle that if you round it off too much doesn't really make a triangle anymore. So I'm not going to be real particular, but just so you know how the book is doing it, I'm going to keep consistent with the notes. So in right triangle ABC, angle A is 50 degrees. Let's mark that. Little c is 15, that's side C, and then they want us to find the rest of the pieces. Now, the sig figs of the side, 2 sig figs. So that means we're going to round the angle to the nearest whole degree. So let's think about our trig functions. Remember sine, cosine, and tangent. So if I'm trying to find little a, I would use my opposite and hypotenuse, which would be my sine function. So we'd say the sine of 50 equals a over 15. I'm going to do this a little fast. On your calculator, that means you would type in 15 times the sine of 50. Make sure you're in degree mode. And because we're rounding to the nearest, well, 2 sig figs in this case, we're going to get 11 centimeters. I'm trusting that you guys know how to type this on your calculator. Now when I'm trying to find little b, we could use cosine because we could do adjacent and hypotenuse. So we could set up cosine of 50 degrees equals little b over 15. And again, to solve this, we would multiply 15 times the cosine of 50. Make sure you're in degree mode. We've already checked it, you're fine. And I think that comes out to 10. Now, because it's 2 sig figs, you should technically put a decimal point after it. But again, I'm not going to be super picky about this. Now, the last thing you're going to need to find is how big that angle is. Well, this angle, triangle will have to add up to 180. So angle B, 180 minus 90 minus 50 is 40 degrees. Those were not the only ways to solve for little a and little b, but that's probably the way most of you would have assumed. Now this next example, we have a triangle as given, and we need to find everything else basically. So first thing I'm going to do is I'm going to find side C. Notice that this is kind of scribbled out here. It's just 3 sig figs. So Pythagorean theorem, we would do the square root. You can leave off the zeros for this part. And you'd get square root of 169, which is 13. Now because of the sig fig issue, we need to write that as 13.0. Again, I'm not going to be that picky. Now we need to find angle A, and we also need to find angle B. And once we find the first one, it's pretty easy after that. So I'm going to use an inverse tangent. I'm going to look at angle A first, and I'm going to say let's do it in blue so it's not confusing. The tangent of A equals opposite over adjacent. So on my calculator, I'd type in inverse tan of 12 over 5. And when I do that, I get angle A is 67.4. Now since it was 3 sig figs, we're supposed to round to the nearest tenth of a degree. So make sure you follow that if you're trying to check in the back of the book, but again, I'm not going to be that picky about it on your homework and on your test. And then angle B, we could just take everything away from 180, so 180 minus 90 minus 67.4, and I think we get 22.6. There you go. And this was C, I should have labeled that. When you solve for all the parts of the triangle, don't just label your picture, write them out into your work like this and box them in, because for your homework check, it's kind of hard to find the answers if you don't box them in and organize them. Okay, this next example is, I believe, out of your book. I believe that's the appropriate page number and end number. And the question here should have said find x and y. It's kind of obvious when you have a problem like this, but that's what we want to do. We want to find x, we want to find y. Now, I think it either tells you or you assume that this is, well, we know it's a 90-degree angle because of how the angles work out here, but angle A is 41 degrees. And then BDC is 58 degrees. And let's see, AB is 18, and then DB is 14. So I'm seeing a larger right triangle and then a smaller right triangle. So we can use our trig functions on those triangles. Let's start with x. This value right here is what we're trying to find. So I think I can set up cosine of 58 equals x over 14, because that would be adjacent over hypotenuse. And when I cross multiply that, I get 7.2, oops, that's supposed to be a 4, 7.4. I rounded 2 sig figs because that's what's going on in this problem. Now, the next part of the problem, I have to think about this large right triangle. And we could do this one of two ways. We can find the entire length, or we can set this up as kind of an algebra problem. So I'm going to kind of set it up as an algebra problem. I want to find y. So what I'm going to do is I'm going to use the cosine function again. So we've got the cosine of 41 degrees. His adjacent side is y plus the 7.4 we just found. And then the hypotenuse is an 18. Okay, so we're going to cross multiply. So cosine 41 times 18. Oh, let's see, that if I type that on my calculator, I get a 13.5848. I don't want to round until the end of the problem, otherwise I'm going to get all funky answers. And then if I subtract off the 7.4, now I can think about sig figs. I think that comes out to a 6.2. It's not the only way you could have found y. You could have called this side something else, like an A, I don't know, or B, whatever you wanted to call it. Find out how big he was supposed to be, which apparently was 13.58, and then subtract off the 7.4. It would have been the same math, but the setup would have looked a little different. Okay, this is a great question. We've got a circle, and he's got a radius of 18 inches. So right away, I know I can label 18 inches right here and right here on my picture. Triangle ADC is a right triangle. So this is a right triangle. Find x, which is just from this point to this point. So what I want you to think about is this angle down here is 35 degrees. What trig function we should be using. So this is the opposite side, and then something's going on here in the hypotenuse. So I'm thinking we're going to use the sine function. So we can set up the sine of 35 equals opposite over, and then the hypotenuse would be x plus 18. And you can't do any cancellations here with the 18s because it's x plus 18. It's a different number than what you're anticipating. Okay, think of this as a proportion now. We're going to multiply, we're going to cross multiply the sine of 35 times the quantity x plus 18. Now go ahead and type in the sine of 35 on your calculator. You're going to get roughly 0.5736, don't round too much yet, times x plus 18 equals 18. And now we're going to use the distributive property and get 0.5736x plus, let's see, on my calculator, it's 10.324. And then we're going to subtract the 10.324, just using our algebra skills now. 7.676, and then we're going to divide by 0.5736, and it comes out to roughly 13 inches once you round to 2 sig figs. I don't think it's exactly 13, but roughly 13. So there are several problems on your homework that are just like that. So if you need to review that, go ahead and play that one more time. All right, enjoy your homework.